got cold water, I got warm water. What I'm gonna do, because you guys, according to your key, my warm water is blue, so I'll put 2 blues. Now what's actually, that is so cool. What's actually moving the water molecules? Yeah. The what? Yeah, the water particles are moving the dye, good. Okay, and all I'm gonna do just really quickly, so it goes faster, just stir and stir. All right, so this is cold on purpose. None of these are room temperature. They're both very cold or very warm. What I'm gonna do is we are going to make sure that these 4 little beakers have the same volume and the same mass of warm and cold water. So for example, what I will do is, this is my hot water. I'm going to pour the same amount in each little beaker. Okay. And you can see that in there. You can see the blues.
Yeah.
Okay. All right. Same volume. It's taking up the same amount of space, volume, and it would weigh relatively basically the same thing, mass. We're going to do the same with my cold water. All right. Okay, so here's what we have. Here's what I'm going to do. For the first experiment, let's start with blue on bottom, and blue is what? Hot. And yellow is cold. Okay, so this is just a piece of cardboard. It's not magical or have any properties. All I'm gonna do is be able to hold it, flip it, and then what I will do is I'm gonna pull this piece of cardboard out so you can see what occurs when we have cold water on top of warm water. Okay, we have a green effect. Okay, what was on the bottom? Hot. What was on the top? Cold. Remember that. Now I am going to do the exact opposite. I'm going to keep the yellow, the cold water, on the bottom, and I am going to put the hot blue water on top. Again, just cardboard. Flip it. Okay. And then I will start to pull. Now wait, we are seeing a little green, but what's starting to reoccur? Yeah, starting. And where's the green stain? In the middle. Now, what's on top in that one? Hot. What's on bottom? Cold. Does anyone have a guess why this one occurred and turned green and this one occurred and turned blue and yellow? Adrian, what do you think?
Because the cold water is high density, so warm molecules can't get in.
Okay, the first sentence was correct. So the cold water has a higher density. Macy?
The pressure is different.
Nope. Yes.
Heat rises, so that's why the warm water went up, that turned it to green, and this warm water is already on the top, so it can't go anywhere else.
Okay, so you're saying warm molecules are going to have a lower density. Now remember, so it'd basically be like lower density is going to typically rise. Lower density is going to typically rise. So that would tell you which of these has a lower density, hot or cold? Hot, because hot's on top. Now, I put hot down here in this green one, and what did he do? Yeah, he tried to rise, and what did my cold yellow do? Started to fall, yep, and then it mixed and created a green. Here, I kept my hot mixture up here and my cold down here, and they're like, yep, we're good, and they stayed where they were. What eventually, let's say in an hour from now, actually in 5 minutes from now, what could start to occur to this one? Zachary,
It starts to fall.
what does?
The hot water.
The hot water is going to start to fall. So what are you going to actually see as proof that the hot water is starting to fall?
It's gonna turn green.
It's going to start to turn green. So in other words, in about, let's say 2 hours, what should this one look like?
Green.
Yeah, the green one. Okay, this one's already mixed. Now that doesn't mean that this is exactly room temperature yet, but it's gonna get there pretty quick because all the molecules started to intertwine. This one, they're gonna try and stay as separate as they can. You can see really, really lightly right here, a green is starting to occur, and you'll be able to start to see that more as time goes on. So